Hi, my name is Amanda Fox, and I've been using CoSpaces for the last year. We've got a bunch of new updates that have came out that I'm super excited about. But one of the other things that makes my nerd flag fly so high is STEM and problem-based learning. So when I'm talking about putting the C in CoSpaces, I'm talking about the 4 C's that go into STEM or 21st century learning. Do you guys know what the 4 C's are? Creativity, collaboration. Here, I'll give you a cheat sheet. Critical thinking, communication, collaboration, and creativity. And I would say one of those mini C's would be coding with CoSpaces. So going with the 4 C's and STEM education, we need to add 2 more C's. That's the coding and CoSpaces. Because CoSpaces really is a transdisciplinary product or platform that you can use in any content area. There are some four small C's I like to acknowledge as well. We have content, community, colleagues, and culture. So when we're talking about CoSpaces and STEM, we want to look at the content that we're actually teaching and make sure that comes before the actual platform. We need to make sure that we're covering our content standards, that we're integrating them in a meaningful way, and we're introducing them in the context of a problem or a design challenge context. The next part is community. When you create a transdisciplinary unit with your other colleagues in your building, so when you work together to design a transdisciplinary unit with them, each subject is breaking those silo barriers, and they're working together to create meaningful experiences and show the interconnectivity of each content. And I'm going to go into how we do that exactly in just a second. And that changes the culture of your school and the culture of your classroom when you're working with your other colleagues in your building to create these meaningful experiences. So again, critical thinking, communication, collaboration, creativity. CoSpaces naturally lends to all 4 of these C's, and when done correctly, you're putting content first, you're working with colleagues in your building to build a community in your classroom that changes the culture of learning. The reason why I focus so much on STEM or STEAM education is because there's a STEM advantage that comes with this. And the STEM advantage, if we look at science, that embraces inquiry and curiosity. Technology, those are the tools that we leverage and use in order to make sure that learning becomes more tacit for these students. And then we also have engineering which gives them a visionary purpose and an idea of where they're going, of how things work and how to put things together. And then artistic design. I'm sorry, but STEM done correctly is always STEAM, because there's always that artistic design or communication piece that comes in. How are you going to showcase your ideas? How are you going to bring them across? Because if you have a great idea and you can't communicate them appropriately in an artistic way, then what's the point? And then mathematics, which is the problem-solving piece. So, have you guys seen Field of Dreams? If you build it, they will come, right? I don't agree with that. You know, maybe with baseball, but when it comes to technology and kids, if you let them build it, they will come ready learners to the table, excited and passionate about what they're working on. And the CoSpaces platform lets them build anything their imagination can think of, especially when you give them the constraints and the conditions and you embrace those 4 C's. So this particular project we were looking at history in future cities. And I was teaching a camp, but I have a social studies background, also English language arts. I have a humanities perspective. So I approach virtual reality, technology, and STEM education from that humanities perspective, which a lot of English and social studies teachers that I've talked to are like, where do I fit in STEM education? You fit in everywhere. So the use cases from the CoSpaces slide, we have vocabulary, literature, storytelling, dioramas, models, coding, and these are great, but these are still siloed out. Now, you don't have to do STEM projects all the time, but what happens when we bridge these silos? What happens when we combine all of these things together? So we did a VR City project, and in our VR City project, they had to design a future city with at least 5 themes. So in CoSpaces, how many of you use CoSpaces or have used CoSpaces? No? So this platform allows you to create scenes. So we did 5 different scenes, and we gave them 5 pillars of civilization. And I'm going to go to the 5 pillars in just a second. And they had to envision and historically research ancient Sumer. And they had to look at how a city developed over time and what aspects or pillars of society were developed over time. And each slide had to represent that evolution of city development up until modern day. So in terms of government, economy, military, transportation, scientific advancements, education, all of those silos are broken down. We're looking at history, we're communicating our ideas, we're writing, we're building 3D models of cities. We are looking at education, we're looking at scientific tools of discovery. We're looking at pillars of society like economy that have been integrated over time. And each slide transitions and has to reflect it. And then within the CoSpaces space, they had to present and explain why they chose their city to evolve the way it did. And then they had to use research to back up that explanation. So considering what was listed, what things are necessities for a civilization or society to function? What things are luxuries? Would education come first, or would government come first? You have to kind of have a system in place before we can start, and then they even started adding more things like libraries and museums and curation of culture, because once society becomes advanced, they've developed a culture and they start showcasing those things and value the artistic pieces that are brought in. So the pillars of civilization, as mentioned, were government, economy, scientific advancements, military, and education. So using these 5 different pillars, they had to do their research, look at ancient Sumer and other civilizations that had developed over time, compare them, and then make an hypothesis of how they would design their city. And maybe they don't choose the same route ancient Sumer did. Maybe they decide to design their future city differently. They got to also defend their design. This is an example of one of the planning sheets that I used when students were building their future city. So up at the top was their city scene 1, so that you have to name your scene before you can code to go to the next scene. So already I'm having them think about the process of the coding before they've even started building it in virtual reality. So how are you going to activate things in your 3D space? Are you going to activate it, hover, or collide with it in order for something to happen? And then tag item name. Before you can code anything, you have to give it an item name. So before they even go into VR, I'm introducing these terms and we're discussing them. So once they get into the coding blocks, they already have prior knowledge of what blocks they're going to be selecting. And I don't tell them where to look. I let them go through discovery, and they have to find them and then kind of link them together and figure it out. So they had to draw their scene, and they storyboarded their VR spaces before they ever started building them out, because content before platform. So I wanted to make sure that they're using the research in order to inform their designs before they get mystically carried away in the magic of VR, because it happens. So what buildings would a beginning city start with? Why? Who is going to be the tour guide of your future city? Would it be a president or a government official? And how can they communicate information with the viewer? So I explained to them that a VR space is an interactive space. So you want to prompt your viewer to come in and click around and interact with the items. The more interactive, the better. I use a PBL learning cycle. So all of my instructional design processes are steeped in research. This is the STAR Legacy cycle out of Vanderbilt. You start with a problem scenario, and this is what the cycle looks like. You identify facts, generate hypotheses, identify knowledge gaps, engage in self-directed learning, apply your knowledge to the problem, evaluate, and reflect. Now this cycle, this is what it looks like. I use PictoChart, and I give 1-sheeters of the entire project my students are going to be doing. And this gives transparency and it sets expectations from the start. They might not understand in the beginning exactly what we're going to be doing, but they have the whole thing in front of them. So the students who want to get ahead, get ahead. The students who need a little bit more extra help, I can go back, but they have the whole thing. So the plot. The plot is one of the most important things. That's where I contextualize my problem. That's where the critical thinking piece and communication is going to come from. So I'm communicating the problem. So congratulations, you've just been hired by a CSI team. This is for a virtual reality CSI assignment. So in addition to future cities, I do crime scene investigation and I connect VR back to STEM careers. So with crime scene investigation, they're starting to use VR to preserve the integrity of crime scenes so that it doesn't get disrupted by detectives going in, and you can have that actual crime scene, walk around in it and analyze it long after the crime and the crime scene has been deconstructed. So congratulations, you've just been hired by CSI Steampunk CDU as part of the forensic science team, and you'll be using virtual reality to help bring justice to the world. I mean, what's more important than bringing justice to the world? So already I'm empowering these kids. Like, they're role playing. They get to be someone else as they go through this process. And kids love to be someone else. Like, if they're not just, hi, I'm John. Hi, I'm John, crime scene investigator. Give them a coat too. Let them play the part. They love it. So we made badges. They had their crime scene badges. We had 360-degree cameras. They could either build the virtual crime scene with all the artifacts and objects within the CoSpaces library that already exists, or they could use a 360-degree camera, bring in props, stage it, and take a picture like a real crime scene. Some of my kids did both. They loved it. And then in addition to that, if you're teaching a chemistry lab or science, you can bring them out of VR and have a lab component that they do with blood analysis or whatever else. You can weave in reality and back into VR. So the problem, how can we use VR, specifically CoSpaces, to create a crime scene case file? How can we use the scientific process to solve crimes? And what elements go into crime scene investigation? So from there, I gave them access to what a crime scene investigator does, what they're evaluating. We talked about deductive reasoning and suspects and labs, hence the lab that I would bring into play. And from there, they go to the project and the build. So given the materials, which was CoSpaces, whatever crime scene props they brought in, create a crime scene investigation complete with multiple scenes, transitions, and Blockly coding in CoSpaces. You may use a 360-degree photo for the actual crime. You have to use 4 or more scenes. Examples, a crime scene, a police station, a lab, a jail. They have to pull items in and they have to research the profession. They're using writing skills because they were given 2 options. They could be given a cold case file that they had to build, or they got to generate their own crime. They got to make it up. A lot of my students chose to make it up, and they were elaborate crimes. Last week I did something similar with the board game Clue, and my students built Clue out, and I dealt them cards, and that's the room they got. So, Stu, you would be building the kitchen with Mrs. Peacock and the knife. And then what we were starting to do is code the cards to where if you clicked on them, you eliminated them as a suspect or witness. So going further, this is what an actual screenshot from a crime scene investigation video. And right here is actually my entire lesson plan. I'm going to tweet this out, the slide deck out. It's like 14 pages. It goes into how to set up an account in CoSpaces. It shows the videos and materials and the research backgrounds I use for the classes. I made a green screen video, which I'm about to show you as my video hook. I love to hook students with something catchy. I gave you the background footage for that video in case you want to make your own green screen video and personalize it, or you can use me. I'm fine with that. So here is my video. So congratulations, steampunk crime scene investigator. And I have the script in my lesson plan. So you can even take the script that I wrote for this video and modify it and personalize it for your own students. And it doesn't have to be crime scene investigation. It can be any topic that you are studying. But if you're pulling in the writing component, you're pulling in the problem-based learning, you are pulling in communication and collaboration, allowing your students to work together, which is what they really want to do, then you are embracing STEM education and the 4 C's. So this is actually one of the scenes one of my kids made. I told them that they could not be the murderer, that we didn't come to camp to, be convicted of crimes. It had to be someone, a fictional person. But I made this video in Camtasia. TechSmith is around here somewhere too. You should check them out. It's great editing software. And of course, the last piece, it's gonna play all the way through. The last piece is I embed the expectations in the video. They have the whole design challenge. They have this that they're looking at while the video is playing. And I have no pride or dignity when it comes to making videos. I embarrass myself all the time, and my kids like me a lot more for it. It's like I'm just one of them, yeah. So, and when you create that type of culture, they take more risk and they're a little more fearless too. So. Does anyone have any questions about using CoSpaces? I want to pull up one of the spaces. Here's the design challenge that I have, and I will tweet that out for you guys right after this presentation so you have it. I use PictoChart, do one-pagers, send it out to the kids. It's a lesson plan too. This is a one-page lesson plan. If you have to write more than one page, your administrator he's mean. Or you just got to learn that we adapt on the fly. You can't write 10 pages and then in the first page it goes wrong. But going into a CoSpace space, I'm going to take you to this is the clue space we just built. So I had 10 kids working on this. Each kid got their own room. They got their own card. They took pictures. I created the main game board. They had to go in and add their door on the outside and the cards on the outside of the room. And they had to code their door to go to their room. And they had to they had to work and collaborate with 8 other people on the storyline and use deductive reasoning and work backwards. So the first thing we did is we decided who did it, where they did it, and what they did it with. And so here's the actual game board. So we had some people playing around in here yesterday. Let me actually go to my classes. I want to show you. So you can create classes. You have them join with the code. And I had a steampunk camp. So this is what our final space ended up looking like. And they had a ton of fun, not just building the different rooms. They had to use the Clue board game as a blueprint too. So they had to be able to look at the room on the card and the board and try to build that exact same room in 3D. The hardest part for them was trying to figure out the game mechanics and how to go from a multiplayer to a single player game. So there's a lot of transitioning and looking at different medias to be able to do that. Any minute now we will have a Clue game to look at. In the meantime, any questions so far? No? In a teacher workshop I did last summer, we had one teacher build a model cell, which I think there might be one in the gallery as well. I had another teacher do 5 different scenes and cover 5 different habitats the students were learning. And as they went through each scene, they had a guided note sheet that she had, and they had to go through and write down facts of which animals would be there. She had an interactive where you clicked, and that was the exemplar that she gave them before students had to go in and actually build like a 3-scene habitat of their own. Everybody send up a prayer to the Wi-Fi god. Okay, 86, 89. Can I get a 90? Can I get a 91? Can I get a 92, 92, 92, 93? I'm going to tweet this out as well. And in addition to that, our crime scene investigation space that I had a group of 3rd through 5th graders working on. It was like 6 or 7 different scenes that they coded. But I just wanted to give you an idea that even though this is VR and coding, you can use it in any different class, and even better when you bring multiple teachers in. You break down those silos and you embrace those 4 C's of communication, collaboration, critical thinking, and creativity. So I am going to sign off here, and if you guys want to hang out, you can see this space if it ever moves. If not, check Twitter, and when you're in your hotel room later with your heels off, you can enjoy it, looking at the space. You guys are smart, y'all. We're flat. So.